Hi guys, Mrs. Winter here. I will have you know this is my third attempt at this video. And if it comes out really bad, I'm just sticking with it this time. Okay, so here's what we got for now. We are going to multiply and divide rational expressions. In our first lesson, we simplified them. Now we're going to multiply and divide, folks. Hold on to your seats. Okay, let's start with multiplying first, because I don't want to scare you with the dividing yet. Okay, so first it says, simplify each fraction first by factoring. Oh, we love factoring, friends. Factor the numerators and denominators in both fractions. Okay, so 2x squared plus 4x. I'm going to take out a 2x on the top, and it's x plus 2 left after I've GCF factored that. Next, I'm going to look at that trinomial, and I'm going to say what two numbers multiply to 12, but add to -4, and that's going to be x minus 6 and x plus 2. Multiply, and I still have to keep factoring. So I've got x squared minus 9x plus 18. I'm going to factor that. That's x minus 6 and x minus 3. And in the denominator, I don't need to factor a thing. I'm just going to write down 2x. Now, way back on the first fraction, you might have got all excited and saw those x plus 2s. Cancel those right out, right? Now, the rule when to find your final product is you can cross out factors up and down on the same fraction, up and down on the same fraction, or diagonal fraction to fraction, but you can never go straight across the numerator or straight across the denominator. That would be really naughty. Okay, so I crossed out up and top and bottom on the same fraction. Look at this x minus 6 group. Boom, gone. Backing up, and x minus 3 is the only factor left. That was fun. Let's do some more. Oh shoot, look at the next one. Now the next one, we don't even need to factor it. I'm just going to go crazy because these are monomials, and I'm going to multiply straight across the numerator and straight across the denominator. 6 times 3 is 18. When I'm going to put those x to the third and x squared together, their exponents together because that's the rule. So that's going to become x to the 5th y. On the bottom, there's an 8, and then it's x to the 5th again because 3 plus 2 is 5. Now, look at, there's an x to the 5th on the top and the bottom in the numerator and denominator, cancel them right out. And then I'm going to take the 8 and say it does not divide into 18, but they have a common factor, and their greatest common factor and 2 divides into 18, 9. So my final answer is 9y over 4. Super fun. Let's do it. That was multiplying. Now let's try and divide. Okay, now don't panic. Divide is simply a multiplication by the reciprocal problem. Do you remember keep, change, change? I love that. So over x plus 7, I change the divide sign to a multiply, and I'm going to take the reciprocal of the fraction that's after the divide sign. So now that becomes x squared plus 6x minus 7 on top, and 8x squared minus 8x on the bottom. Okay, let's keep going. Now this is just like the problem. We have to multiply the two fractions together. That means I got to factor everything first. So 3 over x plus 7, nothing factors there, but I can factor this trinomial on top. X plus 7, x minus 1. Oh, you probably are getting excited. X plus 7s are going to cancel out. Look at that. Okay, now I didn't factor the bottom yet, but look, they have a GCF of 8x, and then there's x minus 1. Look at that. Now the x minus 1 group is gone. So all that's left in the fraction is 3 over 8x. That was great. Dividing is really multiplying. Keep, change division to multiplication, and change the last fraction by taking its reciprocal. Keep, change, change. Okay, folks, let's look at this crazy complex fraction. Complex, oh dear, fraction divided by another fraction. Don't panic, I'm going to rewrite it. M over n squared minus 9. And now I remember that when I rewrite this, it's really a division problem. But now I know from the example up above, stays the same. So m over n squared. Why isn't my pen writing? I'm frozen. M over n, oh God, my internet again, minus 9 times the reciprocal of this, n minus 3 over m cubed. Okay, division became multiplication. Now, I'm going to take and factor. So that's n minus 3, n plus 3. Great. That n minus 3 group is going to cancel. So those guys are gone. Now, if I have an m on top and 3 on the bottom, there's m squared down below. Now look, everybody on the top of this fraction is gone, but somebody has to take the place in the numerator. There's a 1 because each of those things that we divided out divided in 1 time. And then on the bottom, I have now m. That was exciting. Okay, let's try some examples together. No, we can't because my computer's frozen. Okay, here we go. First one's a divide. So I'm going to keep it as 16x squared y over 24xy squared. Change and take the reciprocal. 8x squared y squared, 9xy. Times 8, folks, because remember, I multiply straight across the top. That's 128. I'm going to add my exponents together to make it x to the 4th, y to the 3rd. 24 times 9 is 216. X to the 2nd, y squared. Okay, I'm going to look at the exponents first. 2 and 4, subtract 2 and 3, subtract them, so there's 1. Now, 128 and 216. Grab this best friend of yours, turn on the calculator, and type in 128 divided by 216. Now, hit the math button. Oh, geez, I'm backwards. It's over here. And then hit fraction, and then hit enter, and this is 16/27. It simplifies it for you. Keeps freezing. I don't know if I can move this up. Oh well. It won't scroll. Okay, so let's factor this guy. Whoa, now it did. I don't know what's going on. It's getting crazy. Okay, so we got x plus 3 times x plus 1. 3 times 1 is 3, and they add together to make 4. Okay, I got to make 6 and a 5, so x plus 3, x plus 2. I'm going to go over here. I'm going to make a 10 and a 3. I'm frozen. So I'm going to go x minus 5, x plus 2, and then I'm going to take out a GCF on the bottom. It's x times x plus 1. Okay, now cross off things that are alike. Plus 3's gone, plus 2's gone, plus 1's gone. Wow. 5 over x. Should I cross off those x's? No. That would be naughty. Okay, let's do this last example down at the bottom here. Remember, this is a complex fraction. I'm going to keep x squared minus x plus 5. Keep the first fraction. It's really a division problem, so now I'm going to multiply by the reciprocal. So what's on the denominator? 5x plus 4 is now in the numerator, and x to the 4th minus x squared. Minus x squared. Stay with me, internet. And I just want to write x squared is on the bottom. Okay, so now I'm going to factor the top. In the top of this, I can take out an x on the first one. So that's x minus 1. The bottom's going to stay x. So I'm going to make this x plus 4 times x plus 1. And over here, I'm going to take out x squared. So this turns into x squared minus 1. Now you might be thinking, nobody's really canceling, but look at this x squared minus 1. That's not done factoring. That's x plus 1 and x minus 1. And when we do that, this x plus 1 cancels here. X minus 1 will cancel. This x from the outside here will cancel into this x squared. We'll cancel into this x squared and make just an x, having an issue, an x down on the bottom. Okay, so now on top, I have x plus 4 and x times x plus 5. And that is my final answer. Complex fractions. We did it, folks. I'm so excited. Oh my gosh. I'm barely surviving with my internet. I'm barely surviving my internet today, folks. It's a rough one today. All right, one more lesson. Bye, guys.